Hey, what's up? It's your old pal, Mr. Cook. We just got done with the first page of the Unit 7 group work. So, and I made a note to say that you need your unit circle, a list of your Pythagorean identities and all that stuff, and then also a list of your formulas, which is like the, sum and difference formulas, half angle formulas, double angle formulas. So make sure that you have that out for the second page as well. All right, so let's go over to the second page now. All right. So it even tells us what to do here. Use the half angle or sum and difference formulas to evaluate the following expression and use exact solutions only. So we're only getting exact solutions. We don't want any silly decimal answers, because I know that you can just type this into your calculator and get some number. That's not what I want. I want the exact answer for this, not some estimated decimal value. And we have hints here that can help you out to solve the whole thing. You just need to know how to read the hints, basically. So what this hint is telling me is that if I need to find the sine of 165, the hint tells me that 165 is the same thing as 135 plus 30. So what I'm going to do is just plug that in for the 165. So I'm going to replace 165 with 135 plus 30, just like the hint tells me to do. And this should be, this should like sound an alarm in your brain, because the sine of two angles added together is a formula that we actually used a little bit earlier, actually in number 4. So we're going to use that same exact formula. The sine of two angles added together is equal to the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. And, we're going to plug those, these numbers in for u and v into the equation. So the sine of u plus v is equal to the sine of the first angle, 135, times the cosine of the second angle, which is 30, plus the cosine of the first angle, so cosine of 135, times the sine of the second angle, 30. Then we just go ahead and look on our unit circle, because these are all unit circle angle measurements, which is how we're able to get the exact answer. And look, just look them up. So the sine of 135, that's just going to be a fraction. It's the square root of 2 over 2. The cosine of 30, if you look on your unit circle, that's just going to be the square root of 3 over 2. And then we have the cosine of 135. If you look on your unit circle, that's negative square root of 2 over 2. And then for the last one, sine of 30, if you look on your unit circle, is going to be 1 over 2. So all of these sines and cosines, remember that they just represent a fraction, a ratio of sides. So that's what these all turn into, just these ratios. For some reason, I've seen kids in the past, they get these, right? And then somehow they magically put them into the cosines and the sines for some reason, which is really weird. These ratios, sine, are represented by these little fractions here, okay? So they just turn into those fractions. That's what the whole purpose of the unit circle is. And sine, it's to find those ratios. And same with all the other trigonometric ratios like cosine and all that stuff. Anyways, now we're going to multiply these values together and simplify it to the best of our ability. So it's just two fractions multiplying together. So square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. And then negative square root of 2 times 1 is negative square root of 2. 2 times 2 is 4. Since they have the same denominator, I can just add the fractions together. So I get square root of 6 plus negative square root of 2, which is minus square root of 2, over 4. And I can't simplify this any further, so I'm just going to leave it exactly like that. And that is my exact solution. So that's number 7. Number 8 is really easy too, especially if you use the hint here. So I'm just going to change that pi over 8 to pi fourths over 2. So cosine of pi over 4 divided by 2. So another way to say divided by 2 is to take half of something. So it should be apparent that we're going to be using the half angle formulas. So the half angle formula that we're going to use on your formula sheet would look like this. Cosine of u over 2 is equal to plus or minus the square root of 1 plus cosine of u over 2. So I'm going to be plugging in this value u, and I need to figure out what that is. So if you look at this and this, the u value should be apparent, because u is the same as pi fourths, because those are both the values that are up above the 2, being divided by 2, that we're taking half of. So I'm going to plug in pi fourths for u. So the equation that I get is plus or minus the square root of 1 plus the cosine of u, which remember is pi fourths, over 2. And luckily, pi fourths is another angle that's on our unit circle, so we can find the cosine really easily. So if you look on your unit circle, you'll see that the cosine of pi fourths is the same thing as the square root of 2 over 2. Now there's like a little bit that you can do to simplify this, but honestly not much. You can choose to divide the 2, or like, similar to distribution, and turn that into the square root of 1 over 2, which is a half, and then square root of 2 over 2, divide by 2, which would be square root of 2 over 4. But it doesn't really look any better or any nicer. So you can just kind of leave it like this if you want, honestly. It doesn't really matter between these two, but this will be your solution pretty much. There's one last thing that you need to do, and that's the following. So cosine that we're looking for is for pi over 8. So what you need to do is just determine where pi over 8 is going to be, because that'll tell you if you're going to actually have a positive or a negative cosine. And if you look on your unit circle, or you just know about the angle measurements, pi over 8 is going to be in the first quadrant somewhere. And since it's in the first quadrant, that means that the cosine is going to be positive. So you can get rid of your plus or minus here, because that's the only reason that you put that in there is because at the very end you need to determine if the angle is going to give you a positive or a negative cosine. And in this case, it's just going to be positive. So you can either write a positive there, or you can leave it out because it's implied that it's positive. But that would be your answer. Okay, so that's number 8. Let's move on to number 9. So number 9 looks really complicated, as it is, but it's actually super easy if you just notice one thing. This is another one of those sum and difference formulas. The exact formula that you're going to look for to reference this is actually the tangent sum formula. So it looks like this. Tangent of u plus v is equal to the tangent of u plus the tangent of v over 1 minus the tangent of u times the tangent of v. So this should look really familiar to you because all of this stuff is the same as what we just started with. You can even tell what the u value is, right? Because the u value in this case is 3x, the v value is 2x. So I can just plug those back in over here. So this whole thing is actually just equal to the tangent of u plus v. So 3x plus 2x. That's all that this was, that's all that was needed for this. And then from here, we just combine like terms if we can. In this case, we can. So 3x plus 2x is 5x. So our answer overall, in its simplified form, is the tangent of 5x. And that's using our sum and difference formulas to simplify. So that's number 9. That was pretty easy. Now we move on to number 10. So number 10 is, it's actually a really easy problem if you notice something. So cosine of 2u has 3 equations that you can use for it. And if you pick strategically, then you don't have to do any work. You just need to plug in a number. But we'll forget about that for a second and see how to tackle these types of problems usually, okay? All right, so what you would want to do first with these problems is identify the formula that you're using and look and see what kind of, ratios that you're going to need to plug in and all that stuff. Also, we have a little bit of a typo here, it looks like, because it tells us that the cosine of u is equal to negative 7 over 25, and the tangent of theta is less than 0. That should probably be the tangent of u, and that also implies that the tangent is negative. So if I have a negative cosine and a negative tangent, that tells me what quadrant my angle u starts off in. And this is going to be really helpful because what we need to do to construct kind of an idea of what this angle looks like, it's going to be dependent on what quadrant that angle starts off in. So these are clues to tell you what quadrant you're in. So if you have the cosine of u, and it's negative, cosine is negative, and the tangent of u is negative, the only quadrant where cosine is negative and tangent is negative is going to be in the second quadrant. Because in the second quadrant, if you remember, the x values are negative and the y values are positive. And remember the tangent is y over x. So a positive over a negative is a negative. That's why both of these are going to be negative. And that helps us to put together a right triangle that gives us our angle u's reference angle. So u will be right here, And then if it's cosine, it's the adjacent side over the hypotenuse. So the adjacent side is -7 on a right triangle, and the hypotenuse is 25. I guess I didn't really mention this when I was putting my triangle together, but always make sure that once you find where the hypotenuse goes, like what quadrant it goes in, that the rest of the triangle, one of the sides has to be the x-axis. So just drop a line directly down to the x-axis and you got your right triangle, okay? All right, now, if I have two sides on a right triangle, I can find the third side by using Pythagorean theorem, but luckily, this is just a Pythagorean triple. The Pythagorean triple is 7, 24, 25, with 25 being the hypotenuse, so that means that this side length is going to be 24. There is the potential for this side length to be negative, but that's only if the side is actually going downwards. This side is going up, as you see, but if it was pointing downwards, like going into quadrant 3 or quadrant 4, it'd be negative instead. So this allows us to find any ratio that we need. We know that the sine would be equal to 24 over 25, and then the cosine is given to us already. It's -7 over 25. And we'd even know the tangent of the angle, which would be the opposite side over the adjacent side. So -24 over 7. But, you know, since we ask you to find cosine of 2u, which is a double angle formula, we can actually just use this formula, which is 2 cosine squared of u minus 1. That's, you know, it creates, like, this is basically like a moot point. You don't need to really do all this stuff because, like, with this particular formula, you already have cosine, so you just like plug it in. So 2 and then the cosine value squared, so -7 over 25 squared, and then minus 1. But just, you know, I wanted to practice this because this is actually what you have to do on the test for the problem that we're going to do that's similar to this. So make sure you know how to do your triangles, and we're going to practice that again here in a second on number 11. But make sure you know how to make your triangles out of this stuff with the reference angles. Anyways, let's finish evaluating this. So we have 2, and then if we square this fraction, -7 squared is 49. 25 squared is 625. And I mean, you know, you can type this into your calculator as it is with the parentheses, and then hit enter. You get a decimal value. You can turn it into a fraction if you want. But I'm just going to do it by hand because I like to have fun. So 2 times 49, that's 98. And then 1, that's 625 over 625. 98 minus 625 is 527, and it's negative. So there's our little cosine of 2u. And that's it for that one. Okay, so now we are done with number 10. We move on to number 11. So number 11, solve each of the following. Given that the sine of u is equal to -3 over 5, where the angle u is between pi and 3 pi over 2, and the secant of the angle v is 17 over 8, where the angle v is between 3 pi over 2 and 2 pi, we want to find the cosine of u plus v. Okay, so we better look up that formula also. So if you look on your formula sheets, you'll see that the cosine of u plus v is equal to the cosine of u times the cosine of v minus the sine of u times the sine of v. So that means that we need to find 4 ratios. We need to find the cosine of u, the cosine of v, and then subtract away the sine of u times the sine of v. So what information are we given? We're actually already given some stuff, like we already know that the sine of u is -3 over 5, so we can plug that in. Sine of u, -3 over 5. And we know the secant of v. Now, as it is, secant really doesn't help because that's not in here, but we know that secant is the reciprocal of cosine. So we actually secretly know the cosine of v also, if we just take the reciprocal here, which is 8 over 17. So we plug that in for the cosine of v, 8 over 17. And then we just keep going and try to solve the rest of this stuff. So let's see here. We know that the angle u is between pi and 3 pi over 2. So that puts it squarely in quadrant number 3. So we draw out quadrant 3, draw the right triangle for it, and again, make one of the sides the x-axis. And then we're given that the sine of u is -3 for the opposite side and 5 for the hypotenuse. So this is a 3, 4, 5 triangle, and actually this adjacent side is going to be -4 because it's over to the left in the third quadrant. So now that we know sine, we also know from this triangle the cosine. So cosine is the adjacent side over the hypotenuse, which means that it's going to be -4 over 5 for the cosine of u. And that's another thing that we needed, -4 over 5. There we go. Now let's find the sine of v. That's the last thing that we need, and for that, we just use this information here. Because we know that the angle V is between 3 pi over 2 and 2 pi, putting it in the fourth quadrant. So we draw our fourth quadrant, we draw our right triangle, and then we use the angle V, and we know it's cosine. So cosine is going to be the adjacent side, so that's 8 over the hypotenuse, so 17. So this is another Pythagorean triple. It's an 8, 15, 17 Pythagorean triple. So that means that this other side over here is going to be 15. And not just that, since it's pointing downwards, it's going to be a negative 15. So we know the cosine already. Now we also know the sine, thanks to this triangle. The sine is the opposite side of the angle over the hypotenuse. So that's negative 15 over 17. And that gives us the last little ratio that we need to plug in there, negative 15 over 17. All right, now we just kind of work on everything, adding together. You can actually use your calculator here if you want, but I want a little bit more practice with my fractions, so I'm going to just do it by hand. Negative 4 times 8 is negative 32. 8 times 17, that's 85. And then a negative times a negative times a negative is a negative overall. And then 3 times 15 is 45. And 5 times 17 is 85. Now when I combine like terms here, the denominator is 85. And then I have a negative 32 and a negative 45, which gives me overall a negative 77. Now 77 is divisible by 7 and 11 only. Those are both primes. And neither 7 nor 11 goes into 85. So this is actually the reduced fraction that we get from here. And you could have just, typed this into your calculator with the parentheses, hit enter to get the decimal value, and then transformed it into a fraction by using that function on your calculator. You would have got the same answer that I got, but this is the answer overall for this problem. All right, now we're moving on to the very last problem, and it's another solve over the interval, and it's looks like a factoring problem with tangent. All right, so what we're going to do is the same steps that we did and all those practice problems that we worked on from page, whatever that was, 749 in the book. So what we're going to do is factor this out. So I need numbers that multiply together to be negative 15, add together to be negative 2. So those two numbers will be negative 5 and positive 3. So this factors to become tangent of x minus 5 times tangent of x plus 3 equals 0. Now I take each of my factors and I set them equal to 0. So I've got the tangent of x minus 5 equals 0. That's one of them. And then the other one is going to be the tangent of x plus 3 equals 0. And, this is a standard procedure for factoring. You set each of the factors equal to 0 and then solve. So I'm going to solve for my trigonometric function first. So I add 5 to both sides and I get the tangent of x is equal to 5. And for this one, same thing. Tangent of x is equal to negative 3. Now to get x by itself, I need to undo tangent. So that's when I do tangent inverse. So x is equal to the tangent inverse of 5. And same thing here, tangent inverse of negative 3 is equal to x. And then, this is not a unit circle value for tangent. So, just go over to your calculator and type that in. Make sure that you are in radian mode. And then type it in. All right, so here we go. So we do tangent inverse of 5. And I get that answer in radians. So I'm going to round it to let's say 2 decimal places, so 1.37. So my x in radians is 1.37 radians. That's the angle. Now remember that tangent is kind of weird because tangent is the same, it's positive in the first quadrant and the third quadrant, and then it's negative in the second quadrant and fourth quadrant. So far what we know is that this angle here, which we just found, 1.37 radians, is going to have the exact same tangent as this angle over here. So I also need to find this angle because this will have the exact same tangent as the angle that I have in quadrant number 1. So luckily, if you remember from geometry, this makes vertical angles. So that means that this angle here that we created here is also 1.37 radians. And all we need to do is just add on this much, or half of a circle, or pi, to get the other radian value. So the other radian value that I can find by taking 1.37, this angle, and adding on a half circle, pi. So plus pi. And let's see what that's approximately equal to. All right, so we use our calculator, this plus pi, and that gives us our radian angle measurement, which would be about 4.51. So 4.51 radians. Okay, so these are my two angle measurements that I get from the first part of the equation. Now let's use the second part of the equation. So I use tangent inverse of -3. That's obviously a calculator thing again, so because that's on our unit circle. So tangent inverse of -3, and I get -0.25. So x is equal to -1.25. There we go. And if I were to graph that out on a coordinate axis, so far it would look like this. All right, so I've got a negative angle, and it'd be -1.25 radians. And just like how we calculated the positive tangent, the negative tangent is going to be similar because you can only find negative tangents in the fourth quadrant and second quadrant. And since they get you the same values, because the period is only, pi or 90 or 180 degrees, that means that this angle here is going to give you the same tangent as this angle over here. So the two angles that we're looking for are this angle that starts at 0 and goes all the way to there, so that angle. And then also this one that starts at 0 and then goes all the way around, and it's just shy of a full circle, or 2 pi. So here's what you need to know. This is a vertical angle, the same as this one. So this is going to be the same thing, 1.25 radians. So if I want to find this first angle here, what I want to do is recognize that this is a half of a circle, or pi radians. And it's not exactly pi radians, it's actually pi radians minus this much, because this makes a half of a circle, and we have to take away this much to find this angle. So our first angle that we have as a solution is going to be found by taking pi and subtracting away that 1.25. And then the second angle that we're going to be able to find, so it goes all the way around for almost a full circle. It's actually just shy by about 1.25. So the second angle that we can find by taking a full circle, 2 pi, and then subtracting away that 1.25. Because that'll, if you go a full circle, 2 pi, and then subtract away this much, it'll give you this angle that we're looking for. So we just do that in our calculator, to find the best approximation. So, I do pi plus that number that it's got, and that would give me about 1.89. So I want to make this as accurate as possible. So 1.89. And then for this one, I just have to add on another pi. So just imagine that I type in 2 pi minus 1.25. All right, and you'll get approximately this answer. 5.03. So 5.03 radians for my last angle measurement. So I'd also add on these 80 angles in radians. I tried to say angles in radians. I said something else. I don't even know what the heck I said. So I've got 4 solutions from this whole thing. I've got these 2 radian values and these 2 radian values. So if I were to take any 4 of these and plug them in for x, even though they're approximate, it should be pretty close. I should get real close to 0 for that. All right, so that's it for number 11, A and B. These were kind of time-consuming problems, but nothing too attainable. Not attainable. Nothing too difficult for this. All these problems are easy to do if as long as you remember the steps and know how to use the formulas properly. All right, so that's it for the second page of the group work. Come by if you need some help in the morning and ask for some help. If you can't do that, just make sure you reach out to your teachers and let them know that you need a little bit of assistance. All right, that's it for this video. Good luck on your test.